Hello everyone, my name is Xiaojing Liao from Georgia Tech. Today I will talk about understand and detect bulletproof hosting on legitimate service provider. This is a joint work of Sumaya, Xianghang, Peng, and Professor Wang from Indiana University, Professor Rahim Bia from Georgia Tech, and Professor Damon McCoy from NYU. Bulletproof hosting are hosting facilities that can store any types of content and executable code. Unlike regular hosts, bulletproof hosting servers can primarily host malicious content like phishing sites, scam, fake shoppings, and command control infrastructure. Originally, dedicated bulletproof host server itself could provide a bulletproof hosting infrastructure and cater it to a malicious criminals. However, the high concentration of malicious content and the reputation for not to responding abuse complaints often cause this entire network of bulletproof hosting service become blacklisted. This increasing pressure has driven many of the bulletproof hosting service providers to transform the way they operate in order to evade the reputation-based blacklisting method. Bulletproof hosting services are now establishing a reseller relationship with the reputable hosting service providers. These hosting service providers are often not complicitly in supporting the malicious behavior. However, at the same time, they do not investigating much effort in proactively detect these malicious activities. This reputable-based service provider offer a good cover for the bulletproof hosting service, allowing them to leverage the better reputation of the parent provider. Also, a mix of both the legitimate and bulletproof hosting resellers largely prevent the blacklisting actions against the host service provider. Furthermore, the bulletproof hosting service rent instead of own the infrastructure. These strategies will enable them to quickly move their clients when they are detected. Hence, blacklisting the reputable service provider is not feasible due to a large amount of collateral damage. Also, blacklisted IP addresses are not useful due to the ability of bulletproof hosting service to move their client to a new IP addresses when they are detected. What is required is the ability to peer into the service provider and identify a set of IP addresses that has been allocated to the bulletproof hosting. That's what we call sublocations. This will enable a mid-ground between the coarse gram AS level blacklisted and the fine gram IP level reputation-based defense. Blacklist IP prefix sublocations will improve our ability to migrate these emerging bulletproof hosting service strategies. To this end, we have created a set of methods to accurately detect the malicious IP prefix sublocations. We run the detector over the sublocations we found over a 9-month period and detect 39,000 malicious sublocations to provide bulletproof hosting, which relate to 3,200 ASs as a reputation platform and 230 million domains as the bulletproof hosting clients. Based on these detected network blocks, we conduct a large-scale study to understand the ecosystem of bulletproof hosting service. Now, I will elaborate the design and implementation for detecting malicious sublocations under the legitimate service provider networks. In our research, we utilized a unique observation that the bulletproof hosting service, even on the legitimate provider's network, need to intensively use DNS to support this mission. Hence, we built our detection technique on top of 1.7 terabytes of DNS data that characterize the bulletproof hosting's activities. Specifically, we run the daily whois scan of the whole IPv4 address spaces. And then we harvest the DNS record corresponding to the collected whois sublocations. Also, we'll obtain the DNS record by accessing a database collecting from IIS Security Information Executable Program. We're thankful to share the data. Additionally, we collect a variety of reputable base lists for ASs, IP addresses, domains, and IP prefix for feature extraction and to support the training of our detection model. This effort also required a ground truth set of legitimate and malicious network blocks. These are hard to acquire since few of them existed. In order to overcome this obstacle, we explore a few options for collecting the representative ground truth, such as directly purchasing hosting package from the Bulletproof hosting service. Once the data is collected, it goes through our processing pipeline. We first build the network block hierarchies to find the sublocations and their owners. After that, features are extracted to train a classifier. For example, we use new features to find the signal of Bulletproof hosting. We use new features to find the signal of Bulletproof hosting service who utilize a front-end proxy to evade detection. More specifically, we calculate the daily domain churn. Intuitionally, the client hosts on the Bulletproof hosting service are much less stable than those on legitimate hosting service. This observation is captured by the domain churn feature. For example, the sublocation of a Bulletproof scan hosting has its clients come and go quickly. Our approach is based upon a set of new features. These features are summarized over our analysis of a massive amount of data as well as the ground truth we purchasing. Of particular interest is the observation that some DMS features, such as domain churn, cannot be easily evaded by the Bulletproof hosting service provider due to the reliance of their service on DNS. Now I will show our study on the modern Bulletproof hosting ecosystem. Our study reports 39,000 malicious sublocations distributed around 3,200 ASs. Also, our study presents new observation of how this service operated to evade detection. Firstly, we look at the role the service provider play in the ecosystem. Overall, we found that 50 service providers account for more than half of the detected suballocations. The ASs with the most detected suballocations was PageTag, hosting 7% of the detected sublocations. Another highly ranked AS we detect in our dataset is VPS-Stream, which we detect 37% of its sublocations, hosting many abusive short-lived domains. These domains host brute force tools, scans, and a long list of other abusive activities. Then we study their degrees of potential completeness by measuring a recycling rate. It captures the magnitude of network blocks turnover in effort to clean up their IP addresses space to avoid AS-based detection method. Interestingly, the AS we mentioned before, such as VPS-Stream, has a recycling rate of 0, which they did not make any effort to clean up the IP addresses with a large number of build complaints. On the other hand, AS with a highly recycling rate, mostly data centers, will actively move around the malicious sublocations between a few owners. Next, we look into the owner of the detected sublocations and trace their hosting movement over multiple networks. We highlight the method they utilize to evade detection by spanning their infrastructures across registries and ASs. Table lists the owner's object managing the detected sublocations. We found a number of owners spanning ASs or even registries. We also found an overwhelming number of whois objects per owner, which with an average of 8 objects, making it more difficult to blacklist their whois objects. We studied the clients of the Bulletproof hosting service by analyzing the complete set of domain hosting on these detected suballocations. We found that 50% of the blacklist domains are used for distributed malware. 46% of them running the botnet command control infrastructure. Also, we found 1.6 million of domains have migrated between at least 2 suballocations. When checking the client's movement between the suballocations and sometimes even Bulletproof hosting services, we found the network movement enabled the domain to survive for a longer period. Table 5 shows, this table shows 5 selected domains hopping between at least 10 suballocations and last for months. On average, we found the moving domains to hop 3 detected suballocations while enjoying an average life of 6.7 months. Now I will discuss some of the limitations of our method. First, our method has a detection latency because only have enough malicious activities shown in the DNS dataset, we can extract the feature from it. Next, the sublocation extraction process in our method is depending on the accuracy of the IP whois dataset. If the IP whois data do not show the allocation filed, such as organization, then we cannot extract the sublocation accurately. Third, we will leave the Bulletproof hosting on cloud as our future work because the whois data cannot extract the suballocation of the cloud hosting accurately. In conclusion, in our work, we show the common strategies for Bulletproof hosting, and we present our method to show the detectable using external data and machine learning to detect the Bulletproof hosting. Also, based on our large-scale detected malicious sublocations, we study the ecosystem and show the effective technique they use to evade the existing blacklists. That's it. Thank you. I'm going to take any questions, comments.
We have time for a few questions. Right, then I'll ask one question. So what's your guess or idea of the stability over time of these results? So if, for example, if you would have done the study 2 years ago, or if you were to do it 3 years in the future, would you think that we would see similar results, or would these Bulletproof hosting services behave totally differently?
Yeah, we saw the evolve of the Bulletproof hosting ecosystem and the strategies to host this Bulletproof hosting evolve. And they used to use a dedicated Bulletproof hosting service, and now they use the reputable service providers. And this evasion technique is what they focus now, and it's what our method captured. Yeah, if they more evolve their method and may have a more dedicated evasion techniques, I think it's still rely on the DNS data, and our method could still capture features from it.
Any guess on what they might be doing next?
Yeah.
All right, thank you. Let's thank the speaker again.